How does the Nusselt number optimize cooling system design? Imagine trying to cool down a hot computer chip or a large engine. How do engineers figure out the best way to remove heat efficiently? That's where the Nusselt number comes into play. It might sound complex, but it's actually a simple concept that helps us understand how heat moves from a hot surface into a flowing fluid like air or water. The Nusselt number is a ratio that compares how much heat is transferred by convection to how much is transferred by conduction. Conduction is heat moving through a solid or still fluid, while convection involves fluid motion carrying heat away. When the Nusselt number is high, it means convection is doing most of the work, making heat transfer faster and more effective. In cooling system design, such as heat sinks, cold plates, or heat exchangers, knowing the Nusselt number helps engineers predict how well heat will be removed from components. It's like a performance score for how good a cooling method is under certain conditions. This helps in choosing the right surface shapes, flow rates, and materials to keep temperatures in check. Engineers use the Nusselt number to compare different designs. For example, they might test various fin shapes like pin fins or wavy fins by calculating their Nusselt numbers. The design with the higher number indicates better heat transfer performance. This comparison allows for smarter choices when developing cooling solutions. The Nusselt number also depends on other factors like fluid velocity, temperature difference, and surface geometry. Engineers use correlations that relate the Nusselt number to the Reynolds number, which measures flow speed, and the Prandtl number, which describes fluid properties. These relationships help optimize flow channels and surface features to boost heat transfer without creating too much pressure loss. During the design process, the Nusselt number allows quick estimations of how a cooling system will perform. Instead of running expensive computer simulations every time, engineers can use formulas or models based on the Nusselt number to test many ideas rapidly. This speeds up the development cycle and helps find the best design faster. It also helps predict how a cooling system will behave under different conditions. If the flow rate increases or the temperature difference changes, the Nusselt number can show how much more or less heat will be transferred. This ensures the system remains effective across a range of operating scenarios. Finally, the Nusselt number helps balance heat transfer with pressure drop. Increasing flow speed can improve heat removal but also raises energy costs and flow resistance. By combining Nusselt number data with friction factor information, engineers can find the sweet spot where cooling is efficient without wasting energy. In summary, the Nusselt number is a key tool for designing better cooling systems. It provides a clear measure of how well heat is transferred through convection. Using it, engineers can improve surface designs, flow conditions, and material choices to create cooling solutions that are both effective and efficient.